Now, one final point for today. How do we tell if a first order differential equation is linear? Well, we can say that they're linear if they can be put into this form. Now, we've got y dash is equal to some function of x multiplied by y is equal to some function of x, where y itself might be a function of x, don't forget. Now, if any of these three are actually 0 or 1, it might look like they're missing. And so it might sort of seem as though perhaps it's not a linear differential equation. But a little bit of rearranging can sometimes force it into this form so that you can tell if it's a linear one or not. So I've got some examples here. Now, these three here are quite clear and easy to see that they are linear first order differential equations. So we can see here we've got y dash, we've got some function of x, and it doesn't matter which one of these is our function of x and which one of them is 1, or perhaps y is minus 5 or f of x is minus 5. You can definitely have a function of x that's a constant. You might just have x being raised to the power of 0, for example, in that function of x. So this fits the bill, and then g of x could also be 0. Same thing here, we've got our y dash, we've got y, and we've got some function of x. Negative 6 can be a function of x. It's just minus 6x to the 0. And in this one, y dash plus 4xy, that looks even more obviously like that. It's equal to some other function of x. So these three are really easy to spot. These three are a little bit harder. We might need to do a bit of work to rearrange them. So, actually this is meant to have a y dash in it. So this one, it's got the y dash, so it is a first order differential equation, but we need to rearrange it a bit so that the y dash is by itself. So the way we'd need to do that would be to divide all three terms by x squared. Now, we can't divide by x squared if x is equal to 0. So we'd have to say, assuming that x squared is not equal to 0, because if it is, we can't do this, then we could divide this term by x squared and say we've just got y dash, divide x by x squared, and that'll give us 1 over x, and divide 0 by x squared, and we'll have 0. And now it's in that form, y dash plus some function of x equals another function of x. This one would need to get the y dash by itself. If we want it to be positive also, best to divide by negative e to the x. Now when you're dividing by something, consider that that means that thing that you're dividing by can't be 0 anymore. Well, e to the power of x or negative e to the power of x can't be 0 anyway, so we don't even need this disclaimer, we can just go ahead and do it. So if we divide this term, we're going to have y over negative e to the x, a bit messy, but that's okay. And then we're going to have our minus y dash, and then we're going to have minus 1 over e to the x. And so it's almost in this form. Oh, sorry, that's going to be a plus, isn't it? Because we've divided by negative e to the x. And it's in this form. These two terms could just be rearranged, but it's there. Now for this one, we need to get the y dash by itself, so we need to divide by the sine of x. So that means the sine of x can't be 0, otherwise we won't be able to force it into that form. So you'd need to put that little disclaimer there. Let's write it underneath here. If sine of x is not 0, then we can say that y dash dividing by sine of x is equal to, minus y, and then we've got cos x over sine x, which is going to be cot x, is equal to 1 over sine x, which is going to be cosec x. Sorry, that's a little bit messy and my blue pen is not great. Hopefully you can still read that. So we've forced it into this form. We've got y dash, we've got y, and a function of x is equal to a function of x. But we've also got a disclaimer that tells us that it's only if sine of x is not equal to 0.